join me in a warm welcome to Annoesjka Cabo.
Thank you. Thank you very much. Well, I'm thrilled to be here actually. So you will find out later on also why. And also I have to apologize for my English because I will sometimes be looking for words, but I hope it will be okay. Yeah, okay, but still, you're not being okay, right? So I have a few questions that I would like to ask you, and let's see if it's working. So I will use Turning Point, but I have a European license, so you have to be on the European website. We just tried it with Molly, it does work. So if you can go to responseware.eu. So you are allowed to use your cell phone during this talk, but not all the time. And this is just, I will not have a question immediately after, so we can do this again, but just to see if it's working, so if you can see. So you don't have to fill in any other things that. Yes, that's why there's not an active, because there's not an active slide yet. Okay, so the talk is about innovation. Or innovating and education at a large scale, and then what, why, and how. So it's a very general title. So let me explain a little bit what I want to do. So first of all, you could say why and what would you like to innovate. I will explain the why later in the talk. And it started all with our mathematics educations for engineers. So this is not the mathematics for the mathematics program. We will discuss a little bit what we can learn from this. But there was really a need for that I will explain. So that will also be in why. And how, I think that is the part that maybe I want to share with you, and maybe you can share some things with me. Because the lessons that we learned from this program, how to do such a thing on a large scale, maybe it is something that we can learn from each other and see if we want to do something similar. Okay, so, so Molly already told you a little bit about myself. So I'm an associate professor of statistics at the math department of the TU Delft. And after my PhD in statistics, though, I was away for about 18 years playing the violin as a professional in orchestras. And so you probably already see that when you Google me, so that's why I just tell you from the start. And so 7 years ago, I came back to the University of Delft, where I did my PhD, as a lecturer. And I had to teach on probability and statistics and calculus and linear algebra, as our lecturers do. And then after a few years, I was involved in this innovation project. And then a few years later, I became the director of interfaculty education. So I'm responsible for all the mathematics courses that we teach throughout the university from our department. And also I'm now the academic director of what we call the Teaching Academy, which is the community of everybody who's involved in teaching or in education at our university. So that's more or less everybody who's working there. And the aim is to actually form communities of practice, and that teachers can find each other and learn from each other and talk to each other, and also support that is needed for the teaching to be done in a certain way, and to improve the teaching, of course. And we have a physical teaching lab, which looks like this, is very yellow. Yes. So maybe when you come visit Delft, you will have we can show you around. So it's also to experiment. There are some small rooms for do-it-yourself videos or Riva walls and wine. So, but this is not where the talk is going to be about.
Is it that yellow in person?
It is actually that. Yeah,
it's not as bright as that.
It depends on if the sun is shining, because there are a lot of windows. Glass, yeah.
Right.
Yeah. I cannot change it. It was not my decision, but.
If you find a way to visit TU Delft, you should visit TU Delft.
You see that? Yes. Okay. So it's not an advertisement, but okay. Right. So now here. So if you have any questions, by the way, just interrupt. Okay.
I need like real questions.
Yeah. Other questions. Yeah. Just things you want to know. Yeah. No. Thanks. Yeah. You're right. So now you know a little bit about me. So I thought maybe we can find out a little bit more about you. So this is where the turning point questions is coming in. So I was not very creative in thinking about other places that you might come from. So, can you see the question on there?
Yes.
Okay, great. So I should have something like at least 10 and 10 answers.
You need a both.
Hmm?
You need both.
Okay. I will close it then, I think. Not everybody's answered, but that's okay. Also, in the meantime, you will see that the slides I will using have some icons there. So these are examples of the slide packs that we use in our mathematics education now that are developed. This is just sneaky there. Okay, let's see. Okay, most of you from here. So what's the other? Can I?
I was just thinking.
That's it.
Oh,
Okay, right. Okay, so then now we have about 8 people in the room. So we'll see. So what is your main role? And not that I can completely change the talk after I've got your answer, but try to. Okay. So we stick with 8 then. Yeah. Let's see. Aha. Okay, we even have a student. 2 students. That's great. Management and 2 other. Okay, and what's the other? Hi. Okay. So, but then you're more or less like a researcher, or are you also teaching?
We're kind of multiple things, actually.
Yeah. There's not a possibility to have give more than 2. Okay, well, interesting. You have. Okay, so then last question, but this is not on a turning point, and maybe I can use the blackboard, which I'm thrilled to do because I'm a mathematician and I always want to use the blackboard. But so, what are your expectations? Do you have any expectations of this talk? Because it has a very general title. What do you like me? What do you think I was going to say? Let's see if it matches. Anything? Yeah.
Ways to make mathematics more engaging and more meaningful to engineers.
Okay. So ways to engage students. Yes? Anything else?
Teaching at scale.
Mm-hmm. More? Anything else? Yeah?
Yeah, I don't know if this is, if you're gonna talk about this or not, but.
No, that's what I know, it's okay.
But the combination of digital learning and in-person learning.
Mm-hmm.
Like, I don't know if this is your.
So online and offline, so digital
Yeah,
or
what the potential for that is.
what the?
What the potential for that is, what can we do with that?
Yeah. Okay. Well, let's see. Yeah, I could talk about. So who are mathematicians here in the room? That I didn't ask. Okay, so you're all from different engineering, right? That I could have asked also, but okay. So is it? Why is it not? Okay. So I think we will have some of this addressed. So I'll just shortly tell you about something about the story. I called it the story of the Lonely Innovator. Then about the PRIME, which is the Program Innovation Mathematics Education, and what we developed in this. And I will not show you now a lot of the material that we have developed, but I can stay later on, or even maybe if you have some more time afterwards, I have it in the slides, but I think we don't have enough time for that. And then I would like to share, to talk about how this can be done. Okay, so maybe because some of you are all also involved in teaching or know people that are involved in teaching, there's always people, you know, who are really want to change their teaching or who are thinking about how to make it better and how the students can be more engaged and things like that. And it doesn't, it does. But when you think about what happens in research, usually, you know, you work on each other's work, you peer review, you talk to each other, and you continue there's this upgoing spiral. And what happens in education usually is that you have these loose parts. People innovate things, and when they go away, then the innovation is lost. And it would be nice somehow to get, the culture, more a culture of sharing and peer reviewing and knowing what's going on, also in education. And this also involves maybe some educational research to be done in the. So this was not the one of the initial goals of Prime, but I think it's something that we want to work on in the future. So what was Prime? So here it is again. It used to be a project, and now it's become a program because you will see it's a never-ending story. Yeah, it's really it's like that. And so it is mentioned in the report. That's why I'm sort of proud to be here, because do you know this report? There has been a report this has published last year, and there was a survey amongst I think 50 universities around the world, and they were asked, who do you think is an emerging or current leader in engineering education? And TU Delft was named as one of them. Of course, MIT was there also, but since I'm from TU Delft. And then they, in this report, there's a study of 4 cases, also from different universities from around the world. And Prime is one of the cases that has been described there. And then it was only, at the very beginning still. And it's also the reason why I'm here, because we just had 1.5 days of a colloquium on a global state of the art of engineering education, which is merely to find out what we think we need to do to educate the engineer of the future. What skills does he need to have, and how do we have to organize this? All right, so maybe I have to tell you a little bit about Delft Situation, but I tried to make the talk in such a way, that's also why I want to go to lessons learned, that it will not be very context specific, because otherwise the situation, namely in the Netherlands and here, is so different. For instance, we cannot select our students. We have to, everybody that has the right secondary education is allowed to get in. And so that's completely different, of course, with here. Some programs are allowed to select, but most of us are not. So we have 8 faculties of engineering and about 25,000 students, which is what the university thinks is the maximum, but we are already at this point now. And these numbers are increasing. So it's something we have to think about how to deal with that. And this is the number of scientific staff that we have in the university. So they're doing the research and the teaching. And about 2,000 PhD students. These PhD students are not considered really students in the Netherlands, but they also have a sort of a job. Okay, so what is mathematics doing here? Well, we have our Delft Institute of Applied Mathematics, where statistics is one of the sections, and applied probability, etc., mathematical physics. At the Faculty of Electrical Engineering, Mathematics and Computer Science. And so we have the interfaculty educations, so which is mainly bachelor, but also some master courses. So we serve about 15,000 students per year, and we do that with 48 of our FTE staff. And of those, 23 are dedicated lecturers. So in principle, they do not have a research assignment. But as you can see, we cannot manage only with them. And then, of course, we have our own mathematics program, which has about 550 students. And for the education, we need about 20 FTE per year. Right. So the question was, so the first, or the main part of the talk will go, I will talk about this interfaculty education, so not about the mathematics, the real mathematics maybe. Because the point is, of course, that the mathematics is considered to be, of course, the basic for all the engineering programs, right? And students did not really, or don't really, not always like mathematics, because they went to universities to study civil engineering or architecture, so why do I need math? Okay, but of course we know that they need math, first of all, to understand the other math courses that they will have to do, like differential equations, say, and to understand the physics courses that they have, and also that they were going to apply the math in their own subjects. And so there was really a problem of motivating and activating the students. And we also have a system that in the first year of the studies you have to have 3/4 of the courses, you have to, how you call it, you have to have the points for those, but not all of them. And then they would, sometimes choose not to do the math and delay it until the second year, for instance, and they could go on with their studies and then not having the math. So it really was quite something to think about. How can we actively involve the students? So that was one of the goals, and so also to make the passing rates higher if we can. And then we thought of the ways of transferring the mathematics to engineering, so getting examples from the engineering into the math courses to show the students why they were actually doing the whole thing. And then also, because of this increasing number of students, maybe we can gain something in efficiency preparing and also teaching the courses. Because we used to say that we teach the math in small groups. So, and small, we thought like 30 people in a group. But now we call very small, between 50 and 70 students in a group. And for instance, if you have a first year computer science bachelor year of 900 people, then you have already more than 13 groups, parallel groups that have been going to be lectured like this. So it's also necessary to have some uniformization between the lecturers, because the students, of course, need the same subjects or the same, well, material. Okay, so then, well, I will say what the outcomes of it. But so these are the main goals. Maybe we still have a look at what it's about. It's because of the scale, maybe large scale. So in the beginning, when we started, there were a few enthusiastic lecturers involved. So I will tell you a little bit later how it was organized. In developing the courses, but also, well, I think there were 2 more teaching courses also. And we did pilots with calculus, linear algebra, probability and statistics at different faculties. So the civil engineering did the calculus course 1 and 2. They don't have a third one. And electrical engineering for probability and statistics, and aerospace engineering was a pilot for the linear algebra. And the original plan was that after this pilot, the whole university would do the math in the other way. So it would then there would be crosses all over the place. But that, of course, was impossible, because we found out after the pilot that the material that we developed needed so much changing that we had to do another pilot and redesign the whole thing.
So could I ask a question?
Yes.
So the civil engineering faculty was teaching the calculus as opposed to the math faculty?
No, we are teaching, all the mathematicians are teaching in these faculties.
So why is it say, so why
Because
is
it has a different, they all have a slightly different course. So I mean, they all use, say, for instance, Stewart calculus book, but they do not have all the same subjects. So it's not one calculus course that is the same for the whole university.
So it's the students that are civil engineering students?
Yes, the civil engineering student. Yeah, we teach, as mathematicians, we go to that faculty and teach the students. And so, and we tailor-made the examples. So for civil engineering students, we had different examples than for the aerospace engineering students. Yeah, but it's you will see that for mechanical engineering, which is this here, that we now sort of fine-tuned the course so that civil engineering and mechanical engineering have more or less the same course, and the examples differ a little bit. But that's, I think...
So in principle, the whole matrix is filled in, and the X's are where you're doing an experiment, this pilot?
Yeah, these are, yeah, but we will see that we haven't yet done everything. This is what we're doing now. Yeah, so this is what we started this year. The wet works courses are the things that we did this year. So more lecturers are being involved. So this is also a thing that we will come back on later, because we have to train these lecturers, right, to use the blended learning that I will talk about. So there are a lot of aspects here coming. We'll see. Okay, and now for the coming academic year, we are also going to develop a course on differential equation. That is a second year course, and it used to be taught in a big group of 300 students, and now we will do it in slightly smaller groups of 4 groups of 80 students. And so now a lot of things are being done as I'm standing here, developing practicals online and online exercises and videos and things like that. But it's very nice to see how much energy now there is going on. So, okay, well, this is the organizational part. So what are the outcomes? So it's not really now yet what the results are, but what are the outcomes? So first of all, we had to think about a didactical concept. And the didactical concept, in short, is prepare, participate, practice for the student, but also for the teacher, because you have to know what's going on. So this is the blended part. So we expect the students to come to class prepared. And that means that they watch a video, small video about, say, 5 or 7 minutes, and there's a small new topic or an example explained there. Not a complete theory, but just something new. And then in class, they get such a turning point questions as we started with to test whether they understood what has been told in the video. And then, since they are relatively small classes, the lecturer explains some new theory, continuing from where the video has stopped. And then in class, there's also some practicing going on. So exercises from the book until now that they have to do and they can discuss with each other and with the teacher. And then also there is some turning point question after the teacher has explained some new theory to get some feedback if the students understood what he's been explaining. And then when the student goes home, he has to practice, of course. And we have the book exercises, but we also developed online exercises. So we used a platform from a publisher attached to a book. But we now changed it into a platform that we developed together with a startup company, which is really...
Brightspace.
Yeah, Brightspace is the learning management system that we use, but this is a platform really for math exercise. I will show you later on. It's called Graspel, and it's really nice, and students really like. So this is something maybe to answer your question. So this combination of digital and face-to-face teaching. So it's activating the students in class when they're doing the turning point questions. You really feel there is much more going on than when you just are talking 2 times 45 minutes. This is the length of our lectures, yes?
2 questions.
Yeah.
Is it okay?
Yeah, sure, please.
How do you make sure that they watch the lectures before sort of your lecture?
Yeah, that's a good question.
How do you do that?
Well, you can not really, because we cannot punish them or something, or don't
Right.
give points. But the
You
culture...
encourage it, let's say.
Yes. So it's a matter of training also of the lecturers that they don't repeat what is in the video.
So they don't?
They don't repeat what has been said in the video. So they don't explain it again. Of course, when you have this turning point question and you see everybody has a wrong answer, then there's an excuse sort of to implicitly still explain a little bit again. And in the beginning, this was really hard because the students didn't watch and the lecturer didn't want to, of course, start a lesson with everybody looking like, you know, I for instance, I taught calculus and then there was a small video about introducing the complex numbers. And the first question was like, what is 3 plus 2i minus 2 minus 3i? And then a student would ask, what is this I? And then luckily some of the students another student would say, it was in the video. So, but it took I think at least 2 years for the students to get used to it.
Yeah, because it's basically like a culture or mentality.
It
right?
is.
You have to just understand that that's what you have to
Yeah.
do before
And if every time you say, okay, from the video, you know, if you've seen in the video that, and that's at least my way of doing it. There are also teachers who say, okay, who hasn't watched the video? You can go outside and watch it now. It's only 5 minutes. And I can do the turning point question with people who have watched it. And in the time being, then we're all at the same level to continue. But it's really depending, of course, on if you would like to do it like that. But the cultural change in the students is now okay. Because even after they have been used it, for instance, in the pilot at the civil engineering, and in the third quarter they would start with linear algebra, there were no videos, and they would ask, where are the videos? So it's really okay. And also something we did is that we changed the content of the Calculus 1 course, because we had the feeling it was too much some small subjects like, chain rule and substitution rule, things like that, that they did not all have studied at secondary school. So we decided to take differential equations as a red thread, so that they would also not be too familiar to them when they started, and that also made them, for them it was necessary to participate.
One other question.
Yeah.
What's the value of if you can put all the lectures on the video?
Yeah.
What's the value of an in-person lecture?
Yeah, well, it's not everything is on there, so we don't explain the complete course. So we have a website with all these videos. There are about 200 now, and you will not be able to use it as a complete course in calculus or linear algebra.
And I mean, could you do that?
No, I don't think so. Well, you could, of course, yes, you can, because.
But I mean, is there anything that the in-person video, that the in-person lecture offers?
Yes.
That a video can't really offer?
Yeah, it does.
Okay,
Yeah, and we did research on that. So there is, so the guidance of the teacher is important, and also, well, maybe depends on how good the feedback in the online exercises are. But otherwise, they need to get some guidance through the exercises. They need to get some confidence, and also to get some example on how you think about. How you think when you're solving a mathematical problem, right? In the steps, of course, you can do an example in the video, and I know, for instance, people are also finding videos on the internet where this happens, and they're happy with that. But I think there are two things. So the teacher is somehow guiding the student and coaching, and also the other students, well, they can work together. They don't have to come to class. You would say, okay, right. Well, there can be misconceptions, of course, when you do things only online. But I mean, there are online courses, I guess. Yeah.
I guess some say that the model could work if. Sorry, I don't want to throw you off.
No, it's okay.
Off track. I don't want to mess up the rest of your.
No, but go ahead.
But some say that if one has sort of that the videos can basically substitute, essentially, can play the role of transferring information.
Mm-hmm.
And actually, there's some sort of benefit, because like if it takes me a little bit longer than it takes you, then
Yeah.
I can watch the thing twice or three times, and then the whole sort of engagement in small groups with someone, with a tutor or a TA or someone, that basically allows people to engage with it and to wrestle with it, and figure it out, and ask the questions. And
you have much more time to answer questions. For instance, also, I mean, when people are prepared or even have seen more.
For sure.
So I think that's really something that's
Well, thank you. That's great.
Have you noticed if class attendance has gone up, gone down, or stayed the same?
No, it has gone up. Strangely enough. Yeah. and we also just did a research with a colleague from mine from the e-learning department, and we asked the student to self-report their engagement with the material of the course, and we also had a whole set of questions about monitoring by the teacher, scaffolding by the teacher, so guiding them through the process of solving exercises, and their feeling of, and attendance in class, etc. And it turned out that they reported a higher engagement with the material when they were actually in class and had these scaffolding cues from the teachers. And there was a significant gender bias. So the female students did not feel as much encouraged as the male students. Yeah. And also you saw two groups. One was, say, what we call the online group. So they did a lot with the online exercises and the videos watching, and did not really come that much to class. And then the other group, maybe more the offline group, They came to class and studied the book chapters and also the videos. So just more like something like that. Yeah. Okay. Yes. I can continue. I don't know what's next. Oh yeah. So what we developed. So what is one of the outcomes is a lot of content. So we had all these turning point questions, lecture slides. So in principle, the 13 lecturers go to the lecture with the same set of slides, but that is because of course, the turning point have to be in the slides. So you have to have a slide pack. But then all other things like the theory or the definition or the theorems or whatever, you can skip and do it on the blackboard as you're used to, if you like, as long as there's enough time left for the students to really go to work during your class. So of course the videos we developed ourselves, and then these online exercises that I hopefully can tell you a little bit more about. And these arrows mean that there's a constant improving and changing this. And also the discussions that the lecturer has after a class, for instance, now this turning point question really didn't learn a lot, or did not give rise to discussion amongst the students. So we should try and change it. So, and this is going on all the time, which is nice. And so there's a constant improving of material, and I think we hope, of course, also of the teaching. So that's at least what the students say, and also the program directors. So the following courses have the feeling that the math is more alive, but we have to do research on that because feelings don't count, of course. And the things that we're doing are really student and teacher driven, okay? Because all the feedback that we gather from the teachers that are teaching the course and the students that are getting the course are also constantly taken into account. So before I go a little bit more into yes, I think I have time for that. So what did we learn about? So how is this possible? So what are the things maybe that can be copied, if you like, in a different situation? So I was wondering if you had any idea if you want to do something like that, and you want to achieve something, because you can innovate courses, and then people usually say, well, we have had this innovation like 5 years ago, somebody told us to change and it will pass, we'll just do what we did before. But now, as you saw, it increases and it's not going to go away anymore. Do you have an idea? So this is a question where you can type an answer, but you can only type one. So if you want to have 2 remarks, then put it in 1 line. I think it should be possible to get a word cloud from that. So, I mean, it's hard because you haven't really maybe been in the situation, but still. So you want engage students, you want incorporate examples from the engineering programs, and okay, 4 people have ideas. More, Bill? Well, already 5. Maybe I should say I don't know is also an answer. Okay, shall I stop? Okay, I'll do it. Okay, right. Are there a lot of things said once? Adoption in a yes. Static expectation. Yeah. So all of them is true. There's also all things that you have to take care of, and the question, of course, is how do you do that? Okay. So this is what in a very practical way, this is what we did. So first of all, we had a lot of funding, and it's still there. There's also a structural over 1 million euros per year that we may spend on this, so to attract teachers and to have e-learning developers in the team and educational advisors and doing all the videos and training and things like that, and have a project coordinators and students assistants, because this all changing, all the changing of small mistakes in the slides already takes a lot of work. And there are always mistakes, as you know, when you write something up. But there's also training for the people that are doing the videos in presenting in front of a camera. Do you ever think of So maybe usually when you record a video lecture or a lecture that has been videotaped, then it's still different than when I want to explain to you, for instance, what a complex number is. Because usually then what we're supposed to do is to write a script and have slides together with the video. And as soon as you start writing down mathematics, you get very formal, right? We say let x be a real number, or let f be a function, or something like that. And when you're talking to someone, I would explain something to you, I would never talk like that. So it's this kind of things had to be trained. And then in the beginning, we had a very strong external project leader. It was not a mathematician, but it was a physicist, so that was okay. She was accepted by the people that were working. It's a little bit of that, but she was very strong in setting, we are going that way. And there are a few of the mathematics lecturers, of course, involved who were enthusiastic from the start, so that were the early adapters. And then after 2 years, she left because she never has a job longer than 2 years. So then we needed a strong internal project leader, which was me. And why I was strong, maybe first of all, I was accepted because I was one of them. I was director of interfaculty education by then, so I had something to say. And also I'm very enthusiastic about the project, and I believe that it can work. And also I don't take no as an answer if it's, but still it's really, the cultural changes is really tough. And now we're at the stage that we have some younger coordinators that together with the lecturers now do the whole thing, because there are so many courses, it's not possible for one person anymore to go on. So, and the fact that this is still a team that meets a lot of times works. And then there's this, and somebody had this on the previous slide, involvement of stakeholders. So from the beginning, we had a big steering group consisting of a member of the executive board. There were two deans, directors of education, students also in there, and the director of education and student affairs. And they would get updated every 6 months about what we're doing and how it's going. So that's also important. And then of course the evaluation. So we have people that teach the course meet beforehand, and then halfway there's a lunch meeting, and also at the end to see what we can improve and redesign the whole thing. And then there's a lot of training that we do. So for the lecturers, there's training in using Turning Point, there's training in so there's peer observation. So we organized first, the e-learning developer comes to look in your class, how you're doing, how the students are doing. Then people are going to watch each other's courses, but of course there's not so much time to do that. And this year, for the first time, we started doing video coaching. So there's an external party who videotapes just half an hour of your course and tapes you and the students to see if what you're doing is actually activating the students. And of course, this is a little bit, it sounds not so nice, but I got the idea because people said they have this training that you have to do even when you become a tenure tracker and you have to teach. And we have this university teaching qualification that everybody has to do. And I sometimes ask them, so what do you think about it? And I sometimes some parts not so interesting, but when they videotaped my presentations, they said that was really helpful. So then I thought, okay, that might help when we do this. And the idea is that you get this half hour of material, and then you choose 2 fragments, one that you're proud of and one that you think that you have questions about. And then in the small groups with 2 colleagues, they're discussing these fragments with the external coach. So, and it has been accepted, and also they like it and they get new ideas about how to use also the different ways of teaching. So, bit fun. And also do research. Well, we'll maybe come back to that later. Yes, we moved on. Okay, right. So I have just for fun, this is the only training we now give to the students. It's a small video that they have to watch in the first, when they go the first time. Is it okay? Would you like to see it? At a certain point, something strange is happening in the video. So one of the teachers from the other programs emailed me, there's something going wrong in the video, but you will see maybe. I have to see. Oh, no. Wait. Oh, gosh. Where is it? I lost my mouse, that's why. Over there. And then, oh, huh? He did do it, right? Why is it not going? Ah, it has. Yes. Now the subtitles. Let me see if they're not in.
Hi, welcome to this course. In this video, you will learn how this course is set up and what is expected of you as a student. So watch this video and make the most of it. To benefit the most from this course, I advise you to keep up with the program. You see, this is a mathematics course. And to learn mathematics, you need to practice, practice, practice. Sometimes you think you understand how something works when someone shows you the solution, but when you try to do it yourself, you get stuck. This course is taught in a blended form. That means that you work in a flow, which is partly online, at home or wherever you like, and partly face-to-face, on campus. So, what does the workflow look like? Before the face-to-face session, you prepare by doing a pre-lecture activity. You can find the pre-lecture activity for each lecture on the course page in Brightspace. For example, studying a video or doing some exercises. For example, studying a video or doing some exercises. This way, you have had an introduction to the subject. Bring any questions you have to the face-to-face session. Then, you participate in the face-to-face session, which starts with a few online quiz questions. The instructor gets an idea of your understanding of the pre-lecture activity and can discuss questions you have. During the rest of the face-to-face session, together with the instructor, you dive deeper into the topics of that lecture and directly practice what you have just been taught by doing book and exam exercises. Also, applications of your own field of study are shown to illustrate the use of mathematics in future courses. This is your moment to improve your understanding and insight and to ask questions. After the face-to-face session, you practice even more using an online homework system. The link to this system and which exercises you need to do are on the course page in Brightspace. The online homework environment is a good place to practice your skills. To practice insight, however, do exercises from the book and the exercises treated during the lectures. You need both skills and insight to understand the material and eventually pass the course. So, when you have finished your post-lecture activities, the whole cycle starts again. That's how it works. So remember, prepare, participate, practice, and go with the flow.
What's it? Now let's see if I can stop this thing. Yes, I can. Okay, well, so this was just, and we were thinking maybe we should need to make a video also for the teachers who are involved in the courses, but there were so many sessions with other teachers that it wasn't really needed. It turned out not to be needed. Okay, ready for some results? Well, first of all, the results, I think the results that are maybe not the ones that we intended to in achieving the goals or that we thought that would come out. So, but first of all is that we strengthened the community of mathematics teachers a lot, and there's really a lot of talking about how to teach math, and this also. So, and now I come to our own mathematics education. So this has an effect on how people are thinking now about teaching the math courses. So, of course, we have this discussion about how can we do blended learning when we have to teach students to prove a statement, right? So we still don't know, but there are a lot of things are being experimented with. Also, some turning point questions about theoretical, for example, mathematical logic has been used already. Well, there's a cultural change. And there's a lot of continuing professional development going on in the teachers because they're doing all this new stuff. And the students have been become more active. And now let's see if we have some results in the passing rate. So I haven't updated this, and it's not a linear or even exponential growth. So I mean there is some fluctuation, but still. So see the first. So these are the gray ones are what was the old system. Some of them then you see there's not so bad, and then there's usually a drop when we use. Well, here was an exception with a different teacher who left us. So, but you see there's a drop the first time that we used the blended learning, also because the content has changed and everything had to be changed. But it's getting better. So I have to update this now with all the other courses, of course, but that's just not happened yet. And one of the ways we ask students to give feedback halfway the course is this very simple survey. You will notice it's called Continuous StartStop. We asked them just to fill in the form. And with the 900 first year computer science students, we asked them to do it on a turning point. And with a turning point, as you did, just give a short answer. And so usually they say things like continue with turning point questions, start with doing more example exercises in class or something like that, and then stop with also sometimes turning point questions. But here's one of the examples of the outcomes. Last year, you see that the numbers that the thing people want to stop us with are lower than the ones the students like us to continue with. And when we do this in the first quarter and we repeat it in the second and the third quarter, you see that at a certain point they have answers like stop with nothing and continue like you do. So the students are really more or less, well, satisfied. Now that doesn't mean, of course, that they're learning the things that they should learn, but it looks okay.
I think I know from the language, but when you say start with and stop with, you mean start doing or stop
Yes.
doing, not begin the class with and
No.
end the class with. Okay.
Start doing, yes.
Yeah, okay.
So maybe if in English I should say start doing, yeah, all right. So the students can tell us. And also it's so these are, we collect them for the whole course and we give a general answer that we post on Brightspace, and then we also try to actually do some changes that we can. But also every lecturer gets his personal survey answer, because sometimes they would say, oh, please use a microphone or something like that. So if apparently they don't dare tell them like that, but they do use it like that, and then you can easily change that, of course. Did you have a question? Yeah.
I was curious if you thought this, I mean, clearly you're doing this at your university.
Yeah.
Do you think that this method would work for any level of mathematics? Like if you were teaching, I don't know, 5th grade math.
For mathematics students, you mean?
And let's say you were teaching math in elementary or junior high school or something. Do you think the same?
Oh, in junior high school. I think
don't know, like,
yes.
say for like 10-year-olds, 12-year-olds, 15-year-olds, do you think the same thing would, obviously it's a different level, different concepts. Do you think you think the same things that you're learning and that you're refining here would work at that level as well?
Yes, but I think you have to so what we did to develop the didactic concept is really to think what the learning goals are and what learning activities should be developed to help us achieve the learning goals. And I can imagine that the kind of activities that you have to develop for secondary schools would be, or even primary school, would be really different. Might be different, but I think, yes, it could work somehow. But there is, of course, we are guiding, or we're hoping to guide students at a certain level of, how you call it, independent. I mean, that they can do it on themselves, right? Because we are guiding them now really through the whole course with and they should develop, of course, some self work thing, right? So that's also for. Why? What do you think?
I think the concepts could work at any level.
Yeah.
Obviously, exactly what you said, I think they have to be modified. I don't have all the data behind it, but.
Yeah. But also there's the connection between math and physics in secondary school is also something that people are always complaining about. That they don't know what they do, and then one uses a P and an X and they don't recognize the thing. Something.
But
Yeah.
this whole idea of people being prepared
Mm-hmm.
and having some base level of knowledge.
Yeah.
And, I mean, it's just like I remember when, when I was in high school or something, or in junior high, high school, they'd say, you have to read this thing before you go to the
Yeah.
class. And some would read it, some wouldn't.
Yeah.
But something where it actually makes it very simple.
Yeah.
And there's no way that everybody will be at the same level in any classroom. That's sort of an impossible expectation, I
Yeah.
think, but.
Yeah, but it's true, and the reason why we don't say read this chapter because we have been doing this for the last 25 years, and they don't do it.
Right.
And since they're using all these phones and laptops all the time, maybe it was an idea to use digital. Also, there are also some apps I think that already been developed to activate things. Yeah, so there's hope.
Yeah.
Sure.
I agree with you, and I help folks do this sort of thing here. I've personally worked with primary schoolers, like Khan Academy starts with addition,
Sure.
and not in a classroom, but I think you were really explained it all really well. Although maybe somewhat modestly, I would say that maximizing the value of the instructor, the time the instructor and the student spend together. A subject matter expert, now I'm talking about college, not primary school, but a subject matter expert in direct conversation with a learner, it provides a level of value that it will be a long time before machines can do that, because it's very complicated.
And nobody ever said that the teacher is going to be redundant in this whole.
No, more important.
Yeah, more important.
But so it's sort of, you didn't,
that's
say
true.
That, it's really, it's great that the machines can support the instructors to add the value that they best add. Be in a higher level of activity essentially.
I think but this is, now it's been videotaped, but still, I think that even it's possible to activate larger classes, because we have this problem with student numbers increasing and staff numbers not increasing, because I think you can activate larger groups of students with the turning point questions. So I did a course for mechanical engineering second year probability and statistics where I had 300 students in the room, and they were still actively doing things, and then I would ask them to email me if they had the exercises that they would like me to do in class, and so I did that at the beginning of every lecture, so there was still communication, much more than you would otherwise have. So yeah, it works. Anything else?
Just one thought on that it's also that, I think of when I was a student here, so much of the learning it occurred like between lectures or things when 3 or 4 of us were sitting together and just figuring the thing out. That's to me where most of the learning happened there. And so it's almost like that's almost essential. And then some combination of the video and the professor and the teacher complement that.
Yeah.
It's kind of like you need all 3.
Yeah. I think you should really make them work together. That's also.
Yeah, or all 3 can work together.
Yeah.
I mean, when I was a student, we only had the teacher and the learning together, but it's cool.
Okay. Okay. So and also there's less. So since we developed these lecture slides, because for instance tenure trackers that are really have a lot of work with writing proposals, and you all know how this works. They are spending less time in preparing because it's completely clear what they have to do in such a class, and they can use the slides or not, but most of the times they use most of the slides. Okay, so more feedback, we were already talking, and for the students it's nice that they have a more uniformly prepared for the exam, for instance. So I think I'm not going to talk about it because it's finished. So I will skip this. I can talk about it when everybody, but how can I skip this in this? Okay, so I have to go. I hate this when teachers do this. Don't read it. Can I post this at the slide somewhere? Yeah, okay. So
We do have to wrap up.
yeah, okay, we'll wrap up. So the thing is, can we make open books or use open books and incorporate all the material that we've developed in a book on Brightspace? Because already such things have been developed. So for instance, the strength calculus book we could use for this. And so we would like to incorporate more learning analytics. So, but the bottom line is it can be successful and fun, such an innovation, even only if there's teamwork, support, and training. And it's a never-ending story. So that was what I wanted to say. Thank you.
Thank you,
Listening.
Professor Cabo.